Welcome to Physics World Online College, where physics is simplified for you to understand, prepare adequately, and do very well in your exams. In our class of today, we shall be looking at a new topic titled Electric Field 1, dealing with charges, that is, charge bodies, specifically electrically charged bodies. Please remember to subscribe if you have not done so. Do well to share the class video with your friends. You can post it on your Facebook page and other social media handles as well. Put it on your status so that others can see and know that something good is happening in this platform. So we'll continue with our class for today. Electric field. We need to know what it means. If this is a charged body, there is a region or space around this charged body where the electric force of this charge is experienced or felt. That region or space is called electric field. Let's take that. Electric field is defined as the region or space around a charged body where an electric force is experienced or felt. Now, you can also define it as electric field is the region or space where an electric force is experienced by a charged body. That is correct. Now, to represent electric field generated from this charged body, we use electric lines of force, also called field lines or electric flux. I said electric field is represented graphically. Using electric lines of force or field lines or electric flux. Now, take note because you see it in some questions. Both electric field and electric flux are vector quantities. What does that mean? They both have magnitude and direction. So when discussing them, you must take into account the magnitude as well as the direction. Good. Now we will look at the electric force between 2-point charges. Electric force between 2-point charges. Now, let's take a diagram. If this is a charge body Q1, the unit of charge is coulomb. Then is separated by a distance arrow from a second charge body Q2 in coulomb. The distance of separation between the two charge is r in meter. Now, it was a French physicist called Charles Coulomb in 1785 who first studied the nature and magnitude of the electric force that exists between two electrically charged bodies, Q1, Q2, separated by a distance, r. He said, provided that the bodies are small compared to the distance of separation between them, then the force, electric force between the two bodies is the product of the two masses and divided by the square of the distance between them. Let's take that down. I said it was a French physicist called Charles Coulomb in 1785 who studied the nature and magnitude of the electric force between two electrically charged bodies. So he said that provided the bodies are small compared with the distance between them, then the force, then the magnitude of the electric force, is number one, directly proportional to the product of the charges. How do I put that in mass? That is, F for the electric force is proportional to Q1 times Q2. Let me call that equation A. That's according to Coulomb's findings. He also said that the electric force is inversely proportional to the square of the distance between them. Number two, that electric force is inversely proportional to the square of the distance arrow separating them. So how do we put it? We mean that is F is inversely proportional to arrow square. Let's call that equation what? B. So if we combine equation A and B, we will have combining equations A and B gives that the force F is directly proportional to the product of Q1 and Q2 and inversely proportional to the square of the distance between them. I will call this equation C, which is very useful and gives a lead when you are asked to state Coulomb's law. So, which most external exams will ask you, they say state Coulomb's law. How will you say it formally in such question? So let's put it. So I'm going to state Coulomb's law. I'm going to state Coulomb's law. What does it say? Coulomb's law states that the electric force existing between 2 point charges Q1 and Q2 separated by a distance r is, take the first one, directly proportional to the product of the charges, and you now take the second one, inversely proportional to the square of the distance between them. Directly proportional, inversely proportional to the square of the distance between what? Between them. I'm going to add a last line to this, which I will explain later, and acts along the line joining the charges. That is, the electric force acts along the line joining the charges Q1 and Q2. I'm going to explain this last line later. So, which means equation C gives a direct representation of what? Coulomb's law. So, we are saying that Coulomb's law is F proportional to Q1 times Q2 divided by arrow square. Now, let me bring back this hypothetical diagram. Q1 with charge C1 separated by a distance arrow from Q2 with unit coulomb. The distance between them is arrow in meter. Now, according to Coulomb's law, the force of Q1 is exacted on Q2, while the force of Q2 is exerted on Q1. But both forces are equal and opposite. That is, you have an equal but opposite force existing between Q1 and Q2. And that is true according to Newton's third law that says action and reaction are equal but what? Opposite. I will say more about that. Please, I want you to know, if you check this expression, this equation B is also called inverse squared law. Let me put it here. Equation B is also, this equation is what? Inverse square law. If you recall, you will remember that Newton's law of universal gravitation also have this inverse square law relationship. On a proper day, there are questions asked concerning inverse square law only. But that's not the focus of this class. Hence, we continue with our discussion of Coulomb's law. So, if I remove this proportional sign, I will put equal to with a constant k, Q1, Q2 divided by r squared. Let me call this equation 1a. So, if we have calculations to do that borders on the force existing between two charged bodies, equation 1a will be applied. Now, where k is 1 over k is a constant of proportionality, is a constant of proportionality, the constant of proportionality, and is given by k equals 1 over 4 pi epsilon 0, and this have a constant value of 9.0 times 10 raised to the power of 9 Newton meter square per coulomb square. Good. If we put this into equation 1, equation 1a will be written as F equals 1 over 4 pi epsilon 0 Q1 Q2 divided by r squared. Let me call this equation what? 1b. Equation 1b is applied when we assume that the charge Q1 and Q2, as we have here, is situated in vacuum. Hence, we are using epsilon 0, where epsilon 0 means permittivity of free space, permittivity of air, or permittivity of vacuum. Let's take that down. I said epsilon 0 is permittivity of free space or air or vacuum, and it has a value, also a constant value of 8.85 times 10 raised to the power of minus 12 farad per meter. Now, I have said equation 1a or b can be used when the two charged bodies are situated in vacuum, air, or free space. What about if we have another medium that is not air? Let's say, for example, water. What are we going to do in that case? So we say note, if the charges Q1 and Q2 are situated in another medium, for example, water, then the force between them the force between them is reduced and is given by, now I will replace this epsilon 0 with the permittivity of the medium, water. So that force becomes F equals 1 over 4 pi epsilon, that's permittivity of that particular medium, in this case water, Q1 Q2 divided by the radius square. So this permittivity of water has a connection or a relationship to the permittivity of vacuum through what we call relative permittivity. So I will say here that bet permittivity of water, if I call it epsilon W, is equal to relative permittivity times permittivity of what? Of air. So in such question, it's either they give you the permittivity of water, which you use here, or they give you relative permittivity, which you will multiply with the permittivity of air, and then you substitute it into the formula. So I said epsilon W is permittivity of water, if water is not a medium where the two charges are situated, or any other specified medium. It can be any other material. Then epsilon R is relative permittivity. So we'll still come across the use of this later under capacitor. Now let me explain this last line of Coulomb's law, that the electric force acts along the line joining the charges. How do we explain that? Like I've said, the charge Q1 exerts a force on Q2. That force is equal but opposite to the force Q2 exerts on Q1. Then, if Q1 and Q2 has the same sign of charge, that is, for example, positive charge, then the force will be force of repulsion. While if they have opposite charge, that is, Q1 is positive, Q2 is negative, the force will be what? That of what? Attraction. Let's take note of that. So I said, if the charges are of the same sign, then the force is that of repulsion. That is, the force of one of the charges is directed away from the other charge. So how do we put that in diagram? From the other charge, we have that Q1 is positive, the force acts this way, and then Q2 is also positive, the force pulls this way. So it's directed away from each other. So this is what? Force of repulsion. Then, if the charges are opposite signs, if the charges are opposite signs. If the charges are opposite signs, then the force is that of attraction. The force is that of attraction. What does that mean? That is, the force of one of the charges is directed towards the other charge. So how do I put that in diagram? If this is positive charge body Q1, its force is directed towards Q2, which is of negative charge. They are directed towards each other. This is force of attraction. So you take note of that. Now, we can apply this Coulomb's law to solve example 1. We can apply Coulomb's law to solve example 1. Example 1 says, find the force of repulsion between two protons, meaning they are of the same charge, of charge 1.6 times 10 raised to the power of minus 19 coulomb each, which means Q1, Q2 has this value of charge, and the distance between them is 5.3 times 10 raised to the power of minus 11 meter. So how do you obtain the value of the force between them? So solution to example 1. Solution to example 1. We are given Q1 is equal to Q2, which is equal to 1.6 times 10 raised to the power of minus 19 coulomb. Coulomb is the unit of charge. The unit of force is Newton. Now, for this classwork that you have, you will see they gave us the charges as 12 microcoulomb and 8 microcoulomb. You must remove this micro sign to continue in the solution. Micro is 10 raised to the power of minus 6. So be careful to use it in your solution. The distance we are given R is 5.3 times 10 raised to the power of minus 11 meter. Now, we are asked to find the force. And then we are given the value of 1 over 4 pi epsilon 0 to be equal to 9.0 times 10 raised to the power of 9 Newton meter square per coulomb square. Now, how you apply this value is very important, as students normally make mistake while substituting. So I'm going to clear that point for you. Now, using this constant epsilon 0 shows that these two charges are situated in vacuum. So you should take note of that. So we use either of equation. We use equation from equation 1a or 1b. Let me quote equation 1b. We have that F is equal to 1 over 4 pi epsilon 0 times Q1, Q2 divided by the radius square. Now, this Q1 and Q2, you have to substitute the value. We have that F is equal to, listen, in place of this 1 over 4 pi epsilon 0, I'm going to put this value, which is 9.0 times 10 raised to the power of 9. it is not for you to go under and put 9.0 times 10 raised to the power of 9 under here. If you do that, you are wrong. So it should be all of this is what is this value. So this value is at this top times Q1 1.6 times 10 raised to the power of minus 19, Q2 1.6 times 10 raised to the power of minus 19 divided by arrow square 5.3 times 10 raised to the power of minus 11 all square. So please watch out for that substitution. I repeat, do not put this value under here. No, it is all of this that is equal to that value. So it should be at the top, multiplying Q1 and Q2. That's why it is similar to the equation 1a, which is K, Q1, Q2 divided by arrow square. So it is K times and not to be put under. Let's continue with our solution. So F equals, if you multiply this 9 times 1.6 times 1.6, you get 23.04 times 10 raised to the power of, this is 9 minus 19 divided by, if you square this, remember you have to square 5.3 and also square 10 raised to the power of minus 11. The square affect both of them. If you square this 5.3, you get 28.09 times 10 raised to the power of, squaring this means multiplying it by 2. So you have 10 raised to the power of minus 22. So I have F is equal to 23.04 times 10 raised to the power of minus 29 divided by 28.09 times 10 raised to the power of minus 22. You have F is equal to this divided by this value gives you 0.8202 times 10 raised to the power of minus 29. This divide is minus sign, then this minus 22. That gives you F is equal to 0.8202 times 10 raised to the power of minus 29. Minus times minus is plus 22. F equals 0.8202 times 10 raised to the power of, this will give you minus what? 7. So you put it in standard form, carry this minus sign one place forward. The value will increase to what? It becomes minus 8. So we have force F is equals to 8.202 times 10 raised to the power of minus 8 Newton. Newton is the SI unit of force. So that is how to calculate the electric force between two charges. In this case, repulsion, because they are proton positive charge. Good and fine. So you have this classwork here for you too. You have to solve both of them. Post your answer on the comment section. I will reply appropriately. I've told you, remove this micro sign in both charges before you apply it. Also, be careful how you use that constant value K that is given. Thanks for listening. Please share this class video to your friends. Bye.